This lecture is to introduce pressure-injected footings, also known as PIFs. This type of foundation is only suited for granular deposits because the bulb cannot be formed in clays. When the concrete is rammed into the soil during bulb formation, it densifies the sand and strengthens it. The bulb then helps to distribute the weight of the structure into the surrounding soil. The drive tube is installed using a method called bottom driving. A stiff plug of zero slump concrete is placed inside the tube. The ram pounds this plug, and friction pulls the tube deeper into the soil. When the correct depth is reached, the tube is chained off at the top to stop it from advancing further. Continued ramming then forces the concrete to blow out of the bottom, forming the bulb. At first, the name might make you think a pressure-injected footing is a shallow foundation, but that's not the case. It's actually a deep foundation, cast on site with concrete. Each footing is built with a long shaft and a bulb at the bottom, both made entirely of concrete. You may also hear these foundations called bulb piles, Franke piles, or pedestal piles. To understand how PIFs are built, let's look at the installation process. The YouTube animation shows the method step by step. A steel drive tube is used to create the shaft. As the shaft is filled with concrete, the drive tube is gradually pulled back out. Unlike some pile systems, no steel shell is left behind inside the casing. There's also a handout that explains this process in more detail. At the 525 Huntington project, the process was slightly different from the animation. Once the drive tube reached depth, a corrugated steel casing was lowered inside. Rebar cages were then set, and the concrete was poured. These casings can be seen in the construction sequence photos. Afterward, the drive tube was removed. PIFs can only be used in granular soils because the bulb cannot form in clays. When the bulb is created, the ramming process compacts the soil around it, increasing its density and strength. The bulb also spreads the building load across a wider soil area, reducing ground pressure. Another advantage is that the concrete plug at the base prevents groundwater from entering the shaft, so no dewatering is required. For large column loads, PIFs are often installed in clusters, tied together at the top with pile caps.